All right, we are starting on page 99 in the textbook. We are going to be talking about factoring today. So example 1 in the book, factoring polynomials. 12x squared plus 18xy minus 30y. So when we're factoring, the first thing we want to do is see if there's anything in common to all of our terms. So do we have a number that we could pull out of all of those terms? Are they all divisible by the same number?
3?
They're all divisible by 3. Is there a bigger one?
No, because 3's, if you only bigger, 3 won't go into it.
How about 6?
Yeah.
All divisible by 6? What about our variable? Is there a variable that's common to all 3? No. Okay. So if I pull out a 6, what do I have to multiply 6 by to go back to 12x squared? 2. 2x squared. Right, so I'm distributing in reverse. What do I have to multiply 6 by to get back to 18xy?
3xy.
Plus a 3xy. Okay. How about to go back to negative 30y?
Negative 0.5.
Negative 5y. Sorry, 30.
Yeah, I thought it was a 3 too. That's why.
Okay.
That's what we're both like.
It was a 30.
Yeah, you wrote that 0 so
A little
small,
small.
it looks like a letter.
Okay. So that's a 30. Y.
That's better.
Okay. So then if I went back and distributed, so 6 times 2x squared is 12x squared, and then 6 times 3xy, 18xy, and 6 times negative 5y, negative 30y. So I can always go back and check myself. So this would be the simplified or the factored form. Okay. Just rewritten the equation a little bit. And this number that I pulled out is going to be called the greatest common factor. Okay. It was the largest number that I could pull out of all of those numbers. So our second example is x to the 5th plus x squared. So what's the biggest term that I could pull out of both of those?
1.
I can pull out a 1. And how about my variables? Okay. I can pull out an x squared. Okay. So what would I multiply x squared by to go back to x to the 5th? Part?
I'm sorry, but when you call them variables, I'm trying to get the terminology down. The squared, wouldn't that be called an exponent?
Yes, but when I say the variable, that just means the x's. Those are the variable in this equation. So x squared is the greatest factor I can pull out of both of these terms. So what do I times x squared by to go back to x to the 5th?
X to the 3rd.
X to the 3rd. And then what do I times x squared by to go back to x squared?
Just a 1.
Okay. So the greatest common factor that I could pull out was the x squared. Bart?
How did you get 5? You times x squared times x
And the
third. Oh, and you add the exponent.
So what's that called when I'm adding the exponents? Is that the power or the product?
product.
The product, right? The product of 2 plus 3.
The reason you had to use a 1 instead of an x is because if you would have used a 1x in there, it would have changed the x squared to an x cubed.
So I'm trying to pull out the greatest from both terms, or all 3 terms, whichever I'm working with. So let's go and do some of the exercises that are on page 106. We're going to do the evens kind of as we go, so you get lots of practice at each step. So 8a on page 106. You have negative 13n squared minus 52. Okay. Is there a number that I can pull out of both of those terms?
13.
13. So if I pull out a negative 13, what do I have to multiply this by to get back to that?
4. Well, out by 1.
Okay, 1, and how about my variable?
N squared.
Okay, so n squared. And then what do I times negative 13 by to get back to negative 52?
4.
Okay, so there's my answer. So I just want to pull out anything I can and put the rest in brackets. So 8b is 9p squared plus 27p cubed minus 18p to the fourth.
Why are we doing this exercise, pulling it back out and putting it back together? Just
It's called factoring. It's just something you have to do. Is that written in the correct order, first off?
No.
No. Okay, that's probably what I should do first. Which term needs to come first?
27, or no, the 18p4.
Negative 18p to the fourth
27p third
plus 27
plus
plus the 9p squared. Okay. Now, number. Is there a number I can pull out of all of those? A 9. How about a variable? What's the greatest variable?
squared.
P squared. Okay, what do I times 9p squared by to go back to 18?
negative p squared. Negative 2, I'm sorry.
Negative 2 and p squared, right? P squared times p squared will take me back to the p to the fourth. Okay, how about back to the 27p cubed? What do I times 9p squared by?
3p.
Plus 3p. And how about to get back to the 9p squared? Plus a 1. So the 9p squared, that was the greatest factor I could pull out of everything. And that's what's left over. Example C, negative 6, g to the fifth, plus 12g to the fourth, minus 9g cubed. Okay. So are they in the right order? Yes? Okay. What's the greatest number that I can pull out of all three of those?
3.
A 3? If I pull out a 3, what about my g's?
G cubed.
G cubed. I can pull out a g cubed. No. Dang it. I hate this boy.
Hey.
So what do I times 3g cubed by? Go back to negative 6g to the fifth.
Negative
Negative 2. And how about the g?
2 to the second.
G to the second. Okay. What do I times this by to get back to that?
Negative 2. Or no, positive. Yeah.
So 3 to go back to
Positive
12.
4, sorry.
4. And what about my g's?
For the 1, just the G.
Just a g. And how about to get back to this?
Negative 3.
Negative 3.
G. Or no. Let's see.
Right? 3 times negative 3, negative 9, g cubed. So that was my greatest common factor. Back on page 99, the next way we can factor is we factor out something bigger. So example A, we have x plus 3 times x squared plus x plus 3 times 5. This is called grouping. So I want to take the terms that are the same. So what are my terms that are the same here?
X plus 3.
X plus 3. And then I group whatever was left over. So what were the other terms?
X squared 5
X squared
plus 5.
plus 5. It's not too bad.
Now, you need to add, like, to the second power on the x plus 3 because you had 2 of them?
No, because this is part of the rearranging. Remember how we could rearrange when we're multiplying and adding things together? This is an extension of that, where I have two terms that are the same. I put those together and then I group whatever is left over. I'm still multiplying everything. I've just rewritten it.
Oh, okay. That kind of makes sense now. Because you were timesing x plus 3. Is that correct?
Yes.
And now you're still timesing x plus 3 by x squared plus 5.
Right. I've just rewritten a little bit.
But you're not still timesing x plus 3 times itself. You're not supposed to.
I technically am doing everything in this original problem the same in this one. I've just rewritten it. We'll do it some more, don't worry.
I believe you.
Okay. How about this one? Do I have a term that's the same?
Yeah.
Which one?
X minus 2.
Okay, x minus 2. And then I need to group everything that was left over. So what's left over?
X squared minus 3.
X squared minus 3. Okay. This is factoring by grouping. Let's go and do number 10 on page 106A. Says 5x times x minus 3 minus 2 x minus 3. What's my term that's the same?
X minus 3
X minus 3.
times 5x minus 2.
Okay. And then group everything that was left over.
Can we solve one of those so you can show, or
We can.
do them both sides?
B squared plus 3 times 3b plus b squared plus 3 times 2. 2 over there.
Squared plus 3.
Okay, so b squared plus 3. And what's in my other set of brackets?
Which brackets? Can you point to?
What are the terms that are left over that I'm going to group into this
3b plus squared.
plus 2? That was just 2 that went off the board. 3b plus 2.
Now, is that a squared, the b squared plus 3 squared on the second, on the original up above? Oh, no, that was just a 2 you rewrote
Yes.
over. Okay. That's what was thrown outside.
3p times q squared plus 5 plus 7 times q squared plus 5. Okay, what's my term that's the same?
Q squared plus 5
Q squared plus 5
times 3p plus 7.
3p plus 7. Okay. Page page 100, we're going to make our grouping a little bit more complicated. Okay, 3t cubed minus 15t squared minus 6t minus 30. So if we pull out a 3, oops, that's a 2. Okay. Then we've divided in half. Pull out the t squared. Is this about where we were?
Yeah.
Okay. So if I pull the t squared out, I end up with t minus 5. How about in my second set here? What can I pull out of both of those terms? I can pull out a negative 2 times t. I want that to be a minus, so let's pull out a positive 2. That's not going to work. I hate this book. t plus 5.
How would it be plus 5 if it's, oh, that's supposed to be a negative 2 right in front, huh?
Uh-huh. Negative 2. That doesn't work though, really. So that needs to be a negative. For this to work, that needs to be a negative. So for that
And
to,
it would have to be a negative 5 and a positive 2.
yep. Okay, now do I have a term that's the same? I've got a t minus 5 and a t minus 5.
Yeah.
So if I keep my brackets, then I'll have t minus 5. And then what terms are left over? I have a t squared right there
And a 2.
and a 2.
Where'd you get the 2?
Remember, I take the terms that are the same and then I group whatever's left over in the other set of parentheses.
What 2 terms are the same?
T minus 5 and t minus 5.
T minus 5.
So that's the first way to do it.
Oh, okay. T minus 5.
Oh my goodness, I'm going to scream. Okay, a little bit easier way to do the same thing. Is to divide it in half right at the beginning. So are there terms I can pull out from these two? 3
T squared.
and a t squared. Okay. And then what's left?
T
T
plus 5.
plus 5. How about over here?
6.
If I pull out a 6, do I want to pull out a negative or a positive? I want to end up with t plus 5 inside my brackets.
You need a negative 6.
Okay. I want to pull out negative 6. Do I have terms that are the same? T plus 5. And then what's left over?
3t squared minus 6.
3t squared minus 6. So 2 different ways to factor it. They're both the same, they're just written differently. I like this way better.
I agree.
Less steps means less chances for error. Let's go do the ones in the back of the book, page 106. So 12a, we have 6h cubed minus 9h squared minus 2h plus 3. Okay. So we're grouping. Let's divide in half. What can I pull out of the first set of terms? 3h squared. Okay. What do I have to multiply 3h squared by to go back to that? 2h. And how do I get 3h squared back to 9h squared? Minus 3. Okay. So this is what's inside my parentheses, 2h minus 3. So I want to get this so that it looks the same. What can I do to make it 2h minus 3 inside my next set of brackets? What can I put outside? Negative 1. Okay. So that would take me back to negative 2h squared plus 3. So what are my terms that are the same I can group together? 2h minus 3, those are the same in both sets. And then what are the terms that are left over?
3h squared minus 1.
3h squared minus 1. Well, B is 4k cubed plus 6k squared minus 2k minus 3. Okay, divided in half. What can I pull out of these terms? 2
squared.
k squared. Okay, so I want to end up with a 2k and a 3 somehow. How do I go back to this? 2 k plus 3. Okay, so what do I know I need to do over here on this side? I need to pull out the negative 1 because I need it to be 2k plus 3. Then I put my terms that are the same in a set of parentheses and group everything that was left over. 12c is 3x squared minus xy minus 6x plus 2y. What can I pull out of these two first terms? An x. So I'll have 3x. And how do I get an x back to a negative xy? Negative y. Right? X times 3x is 3x squared. And then x times a negative y is a negative xy. How about on this side? I want to end up with a 3x minus a y inside the brackets. What should I pull out?
2.
A 2.
Negative 3.
I need my 3 to be a positive.
So negative
Okay, so if I pull out the negative 2,
2. 3
3x.
plus
How do I go from negative 2 to 2y?
negative
The negative,
2.
Negative 1.
the negative 1, y. Alright. So the negative 2 times 3x takes me back to the negative 6x. And negative 2 times negative y takes me back to positive 2y. Then what are my terms that are the same?
3x minus 1.
3x minus y. And then what's left over?
X minus 1.
X minus 2.
2.
Okay,
Are we having fun yet?
we are having fun.